Now in this video we are going to take up one more problem on projections of solids. How to solve this problem, analyzing and also solving manually. The problem reads as a hexagonal pyramid of 25 mm sides of base and 50 mm axis length rests on HP on one of its edges of the base, which is inclined to VP at 30 degrees. Draw the projections of the pyramid when the axis is inclined to HP at 45 degrees. To do this, so first the edge which is resting on HP has to be perpendicular to VP. So here you can see the edge which is resting on HP has to be perpendicular to VP. So which are all the two edges which are perpendicular to VP? One edge is CD and the other one is AF. So these two are the perpendicular to the XY line. Therefore, in the front view, you will going to get the point in here and here also C dash D dash. So this is also one of the base edges and this is also one of the base edges. How to solve this problem? By writing it on the sketch. First we are going to draw the XY line and I will go to mark VP and HP. So since I want to start the problem, because since one of the edges is resting on HP, so obviously I have to start the problem from HP. So to do that, since I want to construct a hexagon of 25 mm, draw a vertical line in the top view, that is on HP. So you consider any point on that vertical line, and with this, at that point as center, take a radius of 25 and draw a circle. So this circle will going to cut this vertical line at 2 points. You mark that one point as B and the other one point as E. Then by using the compass, you take a radius of 25 with B as center, cut an arc on the circumference of the circle on the left hand side and similarly on the right hand side. Similarly, with the same radius with E as center, cut on the circumference of the circle on the left side and also on the right side. And you mark those points as A, B, C, D, E, F. Then join A to D, B to E and F to C. All these three opposite corners will going to form, the line joining between the opposite corners will going to be the diagonals of the hexagon. Once you do that, you will going to get an intersection point and you mark that point as O and O1 and you mark all these lines with a dark line. Once you do that, now I want to write the front view. What is the front view? The front view height is 50 mm, which is given. So what I need to do? From A to F, you draw a vertical projector to the XY line. Similarly, from B and E to the vertical line, and from O1, when you project this to the front view, you measure a height of 50 mm from the XY line. You mark that point, you mark that as O dash. Then here you mark that point as B dash and D dash in bracket, and then O1 dash is in bracket. Then similarly, draw a vertical projector from C and D to the XY line and you mark that point as C dash is visible and D dash is invisible. Then as we have joined between O to A, O to B, O to C, O to D, O to E and O to F here. Similarly, you join between, as you look from the front view, ABC is near to the observer. Therefore, A dash, B dash, C dash is visible. D, E, F is away from the observer. So D dash is in bracket, E dash is in bracket and F dash is in bracket. As we are joined between O and A, you join between O dash, A dash with a dark line. Similarly from O to B and similarly from O dash, B dash to the XY line. Similarly from O dash to C dash, that is OC, which is also visible. Therefore, you dot between O dash and C dash. Can I able to see O dash, D dash? No, because that is hiding this line, slanted line, O dash, C dash. Similarly for E also and for F dash also. So this is all, and you measure the distance of 25 and give the dimension of 25 here and the height of the pyramid as 50. Once you do that, now we go for the resting on one of the edges. So which is the edge which is resting on HP? The edge which is, there are the two edges which are perpendicular to VP. Which are all the two edges? One is A dash, F dash and the other one is C dash, D dash. If you rest it on C dash, D dash, then you can rotate it in clockwise. and if you are resting on A dash, E dash, then it will going to be rotated in the anti-clockwise direction. Since I want to resist on C dash, D dash, so what I need to do, you take any convenient distance from the first position front view and you mark that point as C dash and D dash. So with reference to this, I want to rotate this entire triangle by an angle of 45 degrees such that the axis of the pyramid is inclined at 45 degrees. But here O dash B dash is visible, so you have a dark line, and O dash O1 dash, which is invisible, which is the axis line, since you have to give the priority to the condition of visibility, so therefore you take O dash B dash with a dark line, so you have a dark line. Then what I need to do, so here with C dash D dash as center, by using the protractor you measure an angle of 45 degree with respect to the XY line and you draw an inclined line. Then you measure by using the compass, you measure the distance from C dash to D dash. Then you measure the distance from C dash to A dash with C dash D dash as center, cut an arc on that inclined line which is at 45 degrees. Why this base is also inclined at 45 degree? Because this 45 plus 90 will going to form 135 since it becomes an equilateral right angle triangle. Therefore, this side will also be equal to 35 degrees. 45 degrees. Because the sum of these three will going to form 180 degree. You know that this is the 45 degree, 45 degree, and this is this perpendicular line. So 90 plus 45 is 135 degree, and this total entire, it will go to form the right angle triangle. So the entire angle of triangle is 180 degree. So 180 degree, therefore 180 of 45 plus 90 will going to give 135. So you will be able to get 45 degree with respect to the XY line. Then by using the compass, you measure the distance from C dash to A dash with C dash as center, cut an arc on that 45 degree line. Then you mark that point as A dash and F dash. Then you measure the distance from C dash to B dash with C dash as center, cut an arc on this. So you got this point which is B dash and then E dash in bracket, then O dash, O1 dash is in bracket. Then through this point you measure an angle of 90 degree with respect to A dash C dash and draw a vertical vertical line with respect to A dash C dash. Then you measure the distance from B dash to O dash, which is the height of the pyramid. From B dash, you cut an arc on that inclined line which you have shown. Then you mark this point as O dash. Then join. As we have joined all these things here, the same thing you need to write including the views. So you join between O dash, A dash to C dash to O dash with a dark line. Similarly, you draw a line, draw a line from O dash to B dash, because O dash is visible, B dash is also becomes visible, therefore O dash B dash is going to be a dark line. Once you do that, now I need to write the top view for this. Draw a vertical projector from A dash and F dash to the top view and draw a horizontal projector from both A and F. These two lines will going to intersect at these 2 points. You mark this point as A and F. Similarly, you draw a vertical projector from B dash, E dash and O1 dash and draw a horizontal projector from E and then from O1 and O to the second position top view, and similarly from B to the second position top view. And these two lines will going to intersect at these 2 points. You mark that point as B and you mark this point as E. Similarly, draw a vertical projector from C dash and D dash to the top view. Draw a horizontal projector from both C and D. These two lines will going to intersect at these 2 points. You mark that point as C and D. And similarly, draw a horizontal projector from O1 and draw a vertical projector from O. These two lines will going to intersect at this point. You mark that point as O. Now once you do that and join A to B, B to C, C to D, D to E, E to F with a thin lines. Don't dark them. Similarly, join between E to O, O to B, then O to A and O to F, and similarly O to D and O to C with a thin line. Once you do that, now it will going to form the boundary of an hexagonal pyramid. So now, how to do that? So here, all the exterior edges of the boundaries of the solids, all the exterior edges of the boundaries of the solids are visible. So you apply from O to E, E to F, F to A to B, and B to O will going to form the exterior edges of the boundaries of the solids. So you dark them. Okay. Then the surface nearer to the observer is visible. As you are writing the top view for this particular solid. So when you look from the top view, both O dash A dash and O dash F dash and F dash A dash will going to form a triangular surface. So as you look from the top view, since the top view of O dash F dash A dash is OAF, so A to F is already darkened, then join between A to O and O to F with a dark line. Once you do that, the edge which is XY line on the front view is always invisible in the top view. Either you can apply, so which is the edge which is on XY line in the front view, which is C dash D dash, will become automatically invisible in the top view. So you mark that point as small c and small d. Then join between C and D with a dotted line, because this is on XY line is always invisible otherwise. So as we know that AF and AO and FO are the two slant edges which is passing this base edge of CD, automatically that will becomes invisible, because two visible edges or invisible edges can never cross each other. So applying that condition also you can do that. I want whether this line is visible or not. Yes, it is invisible, because the visible edges AO and FO are the two visible edges which are crossing this edge. So this is how you will be able to write the second position top view. Still we have this pending out of the points between D to E, C to B, and C to O, and D to O. So to do that, from a point, if any one of the edges is invisible, automatically all other edges from that point are invisible. So what does it mean? As we know, if you consider the point C, you know that CD is invisible, since one of the edges from common point C is invisible. Automatically CO and CB will also becomes invisible. Similarly, you apply the rule, the same thing here also. From D, if DC is invisible, therefore DO and DE will also becomes invisible. Now when you see O1 is visible or not, since some portion of the hexagon at the bottom surface is invisible, therefore O1 will becomes invisible. Join between O and O1 with a big dash and small dash. So which forms this will going to be the axis of the hexagonal pyramid. Now we will go to the third position. The edge which is the base edge which is resting on HP is inclined to VP at 30 degrees, which is the base edge which is resting on HP. The base edge which is on XY line in the front view, which is that point C dash D dash. So this edge is parallel to HP and perpendicular to VP. Since it is perpendicular to VP, you are getting a point here. Since as you look from the top view, C dash D dash is parallel to HP, therefore CD becomes invisible. So from this point, if two of the visible edges are invisible, therefore automatically the third edges are from that point DO and DE is invisible. Similarly, CO and CB is also becomes invisible. And O1 is obviously will be invisible. As we see that the edge which is on XY line, which is that CD, is in true length or not. Since C dash D dash is parallel to HP, Therefore, you are getting the true length in HB. What is the true length of that line? The true length of that line is 25 mm. So here also this is the true length, which is 25 mm. Therefore, here also the same length is considered. Therefore, you have a true length here. And the inclination given is the true inclination. Therefore, from the projections of lines on the true inclination line, you must get the true length. Therefore, rewrite the second position top view by rotating at an angle of 30 degrees to the VP. So to do that, consider any point. From there, you draw a horizontal line. With reference to that point, with respect to the horizontal, you measure an angle of 30 degrees and draw an inclined line. Then, by using the compass, you measure the distance from C to D. Consider any point. From there, you cut an arc on this, which will go into forms D, and this will go into form C. Similarly, draw by using the protractor from the point D with reference to DC. You measure an angle of 90 degrees below this line and draw a perpendicular line from D, and similarly from C also. Then you measure the distance from D to F, which is same as C to A, and transfer it from D onto that perpendicular line, similarly from the point C also. And you mark these 2 points, A and F. Similarly, you measure the distance from C to this point or from D to this point. Both will have equal distances. From C, you cut an arc on that CD line. Then from this point, with reference to CD, you measure an angle of 90 degrees with respect to CD and you draw a perpendicular. Then from this point to O, you measure the distance. Transfer it from this point to that point on that line O. From O, you measure the distance of O to O1. From O, you cut an arc on this perpendicular line. So you got the O1 in bracket, you mark that point. Then what I need to do with O1 as center with reference to O1, by using the protractor, you measure an angle of 90 degrees and draw perpendicular to O1 line. Then you measure the distance from this point to B, which is the same as from this point to E, and transfer it from O1 onto this side will going to be B, and from this point towards this side will going to be E. Then you mark all these points A, B, C, D, E, F. Similarly, O1 and O. Then this is how we will, including all these visible and invisible edges, you copy the same thing here. Once you do that, so this is how you will be able to write the third position top view. Now to this view, I need to write the front view. So to do that, as we know, C dash D dash is on XY line. Draw a vertical projector from both C and D to the XY line. You mark that point as C dash and D dash. Similarly, draw a horizontal projector from B dash, E dash, O1 dash. Similarly, you say from point B, you draw a vertical projector to the front view. Both these two lines will going to intersect at this point. You mark that point as B dash. Similarly, draw a vertical projector from O1 to the O1 dash locus line and you mark that point as O1 dash. Similarly, draw a vertical projector from VE to the horizontal projection drawn from B dash, E dash and O1 dash. These two lines will going to intersect at this point. You mark that point as A dash. Similarly, you draw a horizontal projector from both A dash and F dash to the third position front view and draw a vertical projector from both A and F. These two lines will going to intersect at these 4 points. You mark that point as A dash and you mark this point as F dash and draw a vertical projector from O to the front view and draw a horizontal projector from O1 dash. These two lines will going to intersect at this point. You mark that point as O dash. Once you do that, now we will come to then join O dash to F dash, O dash to E dash, O dash to C D dash, O dash to C dash, O dash to B dash and O dash to F dash. Then join between A dash to B dash then B dash to C dash. Similarly, from A dash to F dash and O dash to E dash you join with a thin line. Now you apply the boundary conditions. All the exterior edges of the boundaries of the solids are visible. Which are all the edges which will going to form the boundaries of the solid, which is O dash F dash. Since it's on the boundary, you dot that line. Similarly, from F dash to E dash, then E dash to D dash to C dash, and C dash to B dash with a dark line, and join between B dash to O dash. That will also form the exterior edges of the boundaries of the solid. The next, the surface near to the observer is visible. Which is the surface which is near to the observer? The entire bottom surface, which is that A dash, B dash, C dash, D dash, E dash, and F dash. This entire hexagonal surface becomes visible because you are rotating this in the top view in the counterclockwise direction, such that that hexagonal surface, as you look from the front view, it should be properly visible in the third position front view. So as we know, F dash to E dash, E dash to D dash, D dash to C dash, C dash to B dash is already, it is visible. Therefore, join between B dash A dash and A dash F dash with a dark line. Now, from a point, if two edges are visible, automatically the third edge is also becomes visible. Which is that point? That is, from A dash, we know A dash F dash is visible and A dash B dash is visible because that will going to form the base of the hexagonal pyramid. So, from this point, which is the point which is a common point for three visible edges, A dash F dash, A dash B dash, and A dash O dash. Since it is already A dash F dash is visible, A dash B dash is also visible, therefore A dash O dash will also becomes visible. You dot them. Similarly, two visible edges can never cross each other. So if you see that two visible edges, so once A dash F dash is visible, therefore F dash E dash O dash is crossing that visible edge. So apply this concept. This as A dash F dash is visible, O dash E dash cannot become visible because two visible edges can never cross each other. Therefore, obviously O dash E dash should be invisible. Similarly, the same explanation is for O dash D dash and O dash C dash. As we see the slant edges of O dash D dash and O dash C dash, both are crossing the visible edge A dash B dash. Therefore, applying this rule, two visible edges can never cross each other. So, therefore, O dash D dash and O dash C dash will automatically becomes invisible. Since the entire hexagonal surface is visible, since O1 dash is on that entire hexagonal base surface, therefore O1 dash will going to become becomes visible. Then join between O dash and O1 dash with dash, big dash and small dash line, which represents that it is an axis. Then this is how you will be able to analyze the problem and solve the problem by manually and show the dimensions of 25 mm, 50 mm here. This axis is inclined and the edge which is resting on H5 line will be at 30 degrees to VP. So here how do I know that my problem is right? Even in the final position you can see it is resting on one of the base edge. The edge which is resting on HP is inclined to VP at 30 degrees. The axis is inclined to HP at 45 degrees and it is a hexagonal pyramid of base is 25 mm and the height is 50 mm. Since we have considered all the data which was given in the problem to solve this, and hence my problem is right.